This section addresses factoring. So we're going to go through a factoring review here where I'm going to go over each of the types that you see listed in this chart. So we're going to start out factoring out the GCF. Those type of factoring problems can have two or more terms. That's what that symbol means. And the answer to one of those looks like a distributive property problem. So it looks like the distributive property. The next one is factor by grouping. It's easy to recognize. It always has four terms, and its answer, when you're finished, will look like FOIL. The next one is factor trinomials. So we know that it's got three terms, but this one is of the form where the x squared term has a 1 in front of it. Its answer will also look like FOIL. I call this one the short method or the shortcut method. This next one is the same one, but I call it the long method because the number in front of the squared term is not going to be a 1. It's going to be something other than a 1, but it will also have three terms, and its answer will also look like FOIL. And finally, we have difference of two squares. So it's got to be 2. It has to be a difference, which implies subtraction only. And both numbers have to be, both terms, perfect squares. So we know it has two terms, and again, the answer will look like FOIL. Now, this should not be the first time that you have seen factoring. So I'm going to go at this as if it were a review and not an introduction to factoring. So let's look at the first one. I have 1, 2, 3 terms, which means it could be factor out the GCF, or it could be one of the trinomial types. I do notice, though, that there is something that goes into 48, 8, and 4, and there's something that goes into x to the 5th, x cubed, and x squared. So that I know that at the very least I'm going to have to factor out a GCF. So 4 goes into 4, 8, and 48. X squared goes into x squared, x cubed, and x to the 5th. Let's see what we have when we're finished. 4 goes into 48 12 times. X squared into x5 leaves x3. 4 goes into 8 2 times. X squared cross cancels 2 of those, leaving just an x. And 4 goes into 4 1 time, and the x squareds cancel. Now look at what's left. In the parentheses, what's left is not one of the other factor types. So I know that I am actually finished factoring that one. So there's my answer. It looks like a distributive property. Looking at my next one, I see only 2 terms. Okay, that means that it could be a GCF or it could be difference of two squares. It's not a GCF because nothing goes into 25 and 9 other than 1, so it must be difference of two squares. It is a difference, it's subtraction. What got squared here was a 5x on the first term. What got squared on the second term was a 9. So with difference of two squares, it's always going to be what got squared on the first term times itself. One's a plus, one's a minus, and what got squared on the second term. And you have your FOIL. There's actually no process really to that. You just have to think about what got squared to make 25x squared and what got squared to make 9. Next one, I have 1, 2, 3, 4 terms, so I know automatically it is factor by grouping. It could be GCF, but when I look at this, I can see there's not anything that they all have in common. Not every one of them has something in common. So we're going to group the first 2, group the second 2, and now we're going to factor out the GCF of the 2 groups. So the first binomial has an A in common, and I'm left with x minus y. Bring down your plus sign. The second one has a B in common, and I'm left with x minus y. Because these two match, that is my first factor, and my second factor is the stuff that's left on the outside. a plus b. So that is factor by grouping. Let's look at the next one. It also has 4, so I'm going to group the first, group the second, and now I can see that I have a negative in between. This causes a problem. It's a situation that's created when you insert those parentheses. You inadvertently create a distributive property. So in order to correct for that, I'm going to have to change the sign on the last term so that when I distribute that negative, it remains as a positive term. Now we just factor out the GCF. GCF of the first binomial is 3. I'm left with x minus y. Bring down your minus sign. GCF of the second binomial is a. I'm left with x minus y. Once again, these two parentheses match, so that is my first factor, and my second factor is 3 minus a, what remains on the outside. So that's factor by grouping. Let's look at the next one. I have 2 terms, so it could be GCF or difference of 2 squares, but the key word here is difference. This is not the difference of 2 squares. This is the sum of 2 squares. So it can't be difference of 2 squares. Unless there's a GCF, I can't do anything with this. And since nothing goes into 25 and 9 other than 1, we say that this binomial is prime. It cannot be factored. Please don't think, I'm going to write this, that it's 5x plus 3, 5x minus 3. That's not true, because that would make a minus sign in between. It's also not 5x plus 3 times 5x plus 3, because if you FOIL that, you're going to get 25x squared plus 15x plus 15x plus 9. So you have this middle stuff. So that doesn't work either. Nothing works unless there had been a GCF. So it's just prime. Looking at this one, I have a trinomial, and it does have a 1 in the front, an understood 1, so it's either GCF or shortcut process. There is nothing that goes into 1, 2, and 35 other than 1, so I know it is the shortcut process. So I write, I'm looking for factors of negative 35 that combine to make negative 2. Make sure you include your signs on these. I know that to get a negative, I need a positive times a negative, and I know that to have negative leftovers when I combine them means that my larger number must be negative. So I believe it is negative 7 and positive 5. Think about it. Multiply those and you get negative 35. Combine them and you get negative 2. So it checks. So because this is the shortcut process, right there is actually my answer. So when I go to make the FOIL, to get an x squared, I need an x times x, and then I need a plus 5 and a minus 7. The next one is also a trinomial. So it could be GCF, it could be trinomial short or trinomial long. There is no number that goes into 8, 10, and 3 other than 1, so I don't need a GCF. And there's not a 1 in front of the squared term. So this is an example of trinomial long. By the way, so is H. So you need to pay close attention because this is the one people have the most trouble with. So we're going to say 8 times negative 3 is negative 24. And I want factors of negative 24 that add up to negative 10. So let's list all the factors of 24 and then we'll figure out the signs. 24 times 1, I'm going to divide that by 2, multiply that by 2. I'm going to divide this by 2, multiply this by 2. I'm going to divide this by 2, multiply the 4 by 2, and I have a list of everything that multiplies to make 24. Now I know I need a positive times a negative to get a negative, and down here, since I have negative, I know the larger number has to be negative. So I put those in. Which one of those pairs combine to make negative 10? You can see that it's right there. Now what makes this the long process is that that's not my answer the way that it was over here when I found the 5 and the negative 7. I still have to go through a process. Bring down, break down, bring down. I'm going to write that down. See if I can get it in your view. Bring down, break down, and bring down. Notice there are 3 things to do, and there are 3 terms. So I am going to bring down the first term, which means just write it again, 8x squared. I'm going to break down the negative 10x into these 2 pieces. I'm going to write the 2 first and then the negative 12. It doesn't really matter, but I'm going to write the 2 first. So plus 2x, because it's a negative 10x that's being divided, it's got to be x's down here, plus 2x minus 12x. So those numbers served a different purpose. They were our breakdown numbers. And now I'm going to bring down that last negative 3. And from here, you're just doing factor by grouping because I have 1, 2, 3, 4 terms. So we group and group. As soon as you see that negative in between, you want to make a correction on your last term to correct for the distributive property that got accidentally inserted. And now we factor out the GCF of the first binomial. Write what's left. Bring down your minus sign. Factor out the GCF of the next binomial. Write what's left. They match, so 4x plus 1 is my first term, and 2x minus 3 is my second term. Let's do another one of those in H, because this is the one that, like I said, takes the most practice. So we're going to say there's no GCF I can factor out. So 10 times negative 18 is negative 180. We want factors that add up to positive 3. Now I have no clue what they are. 180 has way too many factors. So what I'm going to do is I'm going to go through the process that I went through right over here again to generate those factor pairs. I'm going to do that with a different color just so you kind of know I'm doing something different here. All I'm trying to do is find out potential numbers that might multiply to make 180 and add to make positive 3. We'll worry about the signs later. So we start out with 180 times 1. Now because this is even, I'm going to divide it by 2, multiply the second piece by 2, the 1 by 2. It's still even. Divide by 2, multiply by 2. I'm dividing this one, multiplying this one. Now 2 won't go into 45, so I'm going to divide by 3, which means I have to multiply this by 3. Now I go to the 15. I'm going to divide it by 3, multiply the 12 by 3. Now I'm going to go back to the big number again, 36. And since it's even, I'm going to divide by 2, multiply by 2. I can continue to do that until I have all of the factors. So 18, I'm going to divide by 2, multiply by 2. Now I want to show you something. If I now go to the big number and I divide it by 2, and multiply it by 2, it takes me to one that I already had. So I know that I have them all. I'm finished. Now let's worry about signs. To get a negative 180, I need a positive times a negative. To end up with a positive 3 down here, when I add them, I know the bigger one has to be the positive. So it could be this, could be this, could be this, could be this, the bigger one positive, bigger one positive, bigger one positive. Now what I have to do is find the pair that combines to make a positive 3. I know that they all multiply to get 180 because that's how I got them. And I think right here I can get a positive 3 with a positive 15 and a negative 12. So that required a lot of time and a lot of work before we even are ready to factor. So now we bring down the first term. We're going to break down this into these two pieces. I'm going to write the 15 first, plus 15x minus 12x, that's those two pieces, and then bring down the last. We're going to group. I hope you notice the negative that comes in between, so I'm going to make that correction on that last term, and now I'm ready to factor out the GCF. The GCF of 10 and 15 is 5, x squared and x is x. Do your division. 5 into 10 goes twice, x goes into x times. 5 goes into 15 3 times, x's cross cancel. Bring down your minus. I'm going to run out of space, I think. What goes into 12 and 18 is a 6. 6 goes into 12, x 2x times, and now that's a plus. 6 goes into 18 3 times. These match, so that is my first factor, and my second factor is the stuff on the outside of the parentheses. So these factoring problems can take you quite a bit of time. If you didn't follow these or you feel like you can't factor, it is a responsibility of yours to go to the tutoring center or come see me or get help in some manner so that you can factor. The rest of this course is contingent on you being able to factor.